Okay, things we should know for the AP exam. Conditions for a one-prop z-test. Abigail, do you remember? Random. Yes. Yes, okay. Yeah. Yes, it would be NP naught and NPQ naught, or NQ naught. So that begs the question, what is the difference between P naught and P hat, right? If it's a test, you're using your hypothesis, right? If it's an interval, you're using P hat and Q hat, the sample proportion. Okay, so the condition, if you are doing the test, is that you're basing it on the null hypothesis being true. So what proportion do you expect it to be? How many successes do you expect based on the hypothesis? Yes?
I should know this, but what's the little hat mean?
That's your sample proportion. And then the P without the hat. And your P is the population proportion. Okay, so P is population proportion. Damn it. P hat is your sample. P naught is your hypothesis. Okay. So P hat is your sample proportion. It's what you got from your experiment. And P is what you're trying to estimate, the population proportion from your experiment. And P naught is the hypothesized proportion. So Charlie, what is different about the two-prop z-test?
You have to check that both parties are, you have to check the conditions for both parties. So
Right.
both samples are random. Both samples are less than 10% of their respective population. NP1 is greater than 10 and NQ1 is greater than 10 and NP2 is greater than 10 and NQ2 is greater than 10. And that they're independent from each other.
And independent of each other. Okay, that's the big difference, right? You're checking all the same things, but for both proportions. But the big difference for the two-prop z-test is that you have to check that the populations are independent of each other, right? There is no influence. How are those different from a one-sample t-test, Caitlin? Right, so we still check randomness, we still check less than 10%, but we check nearly normal. So we look at a histogram of the data or a normal probability plot. And if you can't check that, what is that sample size that allows us to use the central limit theorem?
30.
How big?
Oh,
30.
God.
If n is greater than 30, we can use the central limit theorem. Yeah. So how is a two-sample t-test different from a one-sample t-test? I'm just doing both samples, and again, we're checking to see if the samples are independent of each other, right? Because if they're not independent of each other and they're matched, then it should be a matched pairs, right? So really for these two, we want to know independent or matched, right? And then all the other conditions for the t-test are the same. Now the one that's most different is the chi-squared test. What are our conditions for a chi-squared test, Devin? Chi-squared Squared. Random. It's a good guess. It's a good. No. Chi-squared, a lot of times we're doing a test to see if they're independent, right? We have a chi-squared test for independence. Data must be in counts. Okay, the data has to be counts. You can't be given percentages. If you're given percentages, it's probably a two-prop t-test. Yep. Expected counts greater than 5. Yes, you can convert the proportions to numbers, but it might be more work than it's worth. And then conditions for a linear regression test. To know. The lin-reg test. I'm going to go this way. Yeah? That is our hypothesis. Our hypothesis for the lin-reg t-test is there an association, so there's no association is our null.
Oh, I got it. Scatter plot is straight up. Oh, the spread and the symmetric. Symmetric is. Oh, the symmetry.
Yes? Histogram or normal probability plot, right, of residuals.
And then for lin-reg t-test, use beta in your hypothesis.
Yes. Right. Our hypothesis is beta equals 0, or beta does not equal 0 usually. So our null hypothesis is that there is no association between the two variables, and our alternative is that there is an association between the two variables.
Beta to be greater than or less than 0?
Yes, it can be greater than or less than.
What would you say in the terms of an association?
I would say there's a positive association or a negative association. Right? Positive for greater than, negative for less than. Okay, Claire, what are the degrees of freedom for one sample t-test? n-1. And Morgan, what are the degrees of freedom for a matched or a two sample t-test? n1 plus n2 minus 2. Because I have to add the two sample sizes together and subtract 2. What about the matched pairs t-test, Delilah? Just back to n-1. Because remember, for matched pairs, you have matched data. So I have your before and after. So really, we're treated as a one sample t-test, and everything we do is the same as a one sample t-test on the differences. Hey, I'm recording. What about degrees of freedom for the linear regression test, Kylie? Close. It's n-2. Because there are two variables, it's n-2. How about degrees of freedom for chi-squared goodness of fit, Jalen? It's kind of. It's the cells minus 1, yeah. Like if we're doing M&M colors, it's the number of colors minus 1, right? So yeah, kind of the different
I always go, can we just like draw the shape of it? I always go like this. Like,
That's fine. It's rows minus 1 times columns minus 1. Yeah, that L where we cover up. Standard error of a mean.
wait, so if you have the parentheses, does that mean row minus 1?
Just S over square root n. Mm-hmm.
What is the like row total times column total over row total?
Q over N is standard deviation.
Wait, say that again. Oh, those are for the expected counts. The expected counts. Row total times column total divided by table total is your expected counts. So the standard error of a mean is S over square root n or sigma over square root n, depending on if you know sigma and mu. What about standard error of a proportion?
So cells are side to side or up and down?
Actually, that's not correct. If it's standard error, it is not sigma. It is always S for standard error. It's standard deviation when we use sigma.
Wait, so anytime it says standard error, it's never...
It's always S, yeah, or p hat. Because we're calling it an error, a standard error, because we're using the estimate we have from our sample instead of the population information. So the standard error of a proportion, Faith. P hat, Q hat over N. Square root of P hat, Q hat over N.
I thought that was standard deviation.
Yep, that's on your sheet.
So I just, if I can just remember which each value is,
Yeah. They are on the sheet. These ones are on the sheet. The chi-square equation for the chi-square test is on the sheet. Your degrees of freedom, yes, you get a calculator for the entire exam, multiple choice and free response. Because the the multiple choice questions are probably going to say like, what is the correct calculation for the chi-squared statistic? And it's going to have all the numbers plugged into the equation, right? So we have to be able to know what the correct equation is for those questions. But yes, you can use the calculator commands on the free response test. Okay. Okay, so the equation for chi-squared test, Robin?
Isn't it the sum of all the components? So like the row total times column total over total total?
So that's your expected count, so the observed minus the expected squared over expected.
That one's also on that sheet.
That one is also on the sheet. Yeah. So your the sum of the observed minus the expected squared divided by expected. And then you have to have it plugged in. I would imagine you'd have something like that. The distribution is skewed right. Is the mean or the median greater? The mean. Or what's another way for skewed right? What's another way for them to say skewed right? Good, positively skewed. So if the distribution is skewed left, the median is greater. If the distribution is symmetric, the mean and the median are about the same. When we are asked to describe a distribution, which is a histogram, a box plot, a dot plot, a stem plot, what do we describe? Yeah, shape, outlier, center, spread. Yours, Ox. What do we describe with the scatter plot? Direction, form, scatter, outlier. Remember, direction is positive or negative, and you want to say the scatter plot is positive as height increases, weight increases. As number of hours worked increases, GPA decreases, like whatever it's talking about. Form is it linear or curved? Scatter, is it really loosely scattered? Is a big cloud of points? Is it tightly scattered around a line so it almost looks like a really good line? Or is it moderately scattered?
Wait, you said form was like
Yes, linear or curved, basically. You don't have to get really specific about the curve, like you don't have to say quadratic or exponential or anything, just it's curved or it's linear. And then outliers. Okay, if you need to use Randit, what menu do you find it on the calculator, Ava?
Math.
Prob 5.
Yes, math prob. But you're not Ava.
My bad. I got so excited. Ava, you can answer the next question.
Okay, Ava, can you tell me what menu normal CDF is in?
I have to get my calculator, but yes. Actually, wait, is it second? Second? No. Second bars.
Right, which is distribution. Right, second vars is distribution. Now, side note, if you can't remember where to find a calculator command, you're like, my brain is blanking. Okay. Keep pushing. Well, it's not like we use every menu, right? I mean, it's probably in the stats, the calc, the right stats, calc, stat, test, or the distribution menu. That's a pretty safe bet, right? But if you don't want to waste time, remember there's catalog above the 0. Go second. I know I've shown this before. Second catalog. You don't have to scroll. If you know what you're looking for, click the alpha button and select the letter you want. So if I want N, I can just hit the log button and then it'll take me to the N's. And there you'll see normal CDF. Catalog above the 0, second catalog. It already is automatically in alpha when you're in the menu. So if I'm here and I hit second catalog, second catalog, it already has the alpha on, right? So if you want normal CDF, say, or binomial CDF, find the letter in green, B, and then scroll down to binomial CDF, PDF. Okay? It's above your 0. Second 0, it says catalog. Okay, so that's if you have a brain fart and forget where something is. Okay, Julia, do you know the difference? Can you tell us the difference between CDF and PDF?
One is for like a group, and one is for just one thing.
Okay, but which one is which?
CDF is the group.
No. PDF is a single value. The P stands for point, single point. And CDF is a range from 0 to the number you give it. It has always from 0 to the number you give it, right? That's why we have to do 1 minus if we want greater than. The C stands for cumulative. So it's adding it all up, like your cumulative GPA. What about, Kaylee, do you know the difference between geometric and binomial?
One of them is like on the something that I took it out, right?
Geometric is the first success on nth trial. So I have my first basket I make on my 5th attempt. And binomial is x successes in n trials. Order doesn't matter. Here, order matters. Like there's an order. You have a failure, a failure, a failure, and then a success. Okay, let's go back. Can two events be mutually exclusive and independent? No, they cannot. What equation do we use to determine if two events are independent? Probability of B given A is equal to the probability of B, or the probability of A given B is equal to the probability of A. What does the law of large numbers say, Valerie? Gianni? Law of large numbers, what does it say?
It says numbers can be big.
The law of large numbers says that as we do more trials, our probability gets closer to our expected probability, right? The theoretical probability. So we can toss 10 coins and we might get 7 heads, right? But the more we toss the coin, if we do it 1,000 times, that proportion of heads is going to get closer and closer to 50%, right? Yeah. Right. It gets, yes, we shuffle the deck 7 times. But I don't think that one's going to be on there. It should be, though. And how is that different from what the central limit theorem says? Mm-hmm.
Sample size. Like, as the sample size gets bigger, as the sample size gets bigger, like the sampling distribution becomes more normal.
Correct.
Even though the population can be skewed.
Correct. Even if our population is skewed, if my sample size is large enough, the sampling distribution will be normal, and we can use the normal model for that. And that's why we use that when we can't look at the data. If our sample size is above 30, we can say that it's large enough to apply the central limit theorem. The sampling distribution will be normal. So we multiply. Or is add. What is the equation for the slope that includes standard deviation of y and x? B equals RSY divided by SX. This is on your formula sheet. If it gives you means and standard deviations and asks for the regression line, most likely a multiple choice question, you have to use this formula to find the slope and then plug in your mean for x and your mean for y and solve for the y-intercept.
Is r being multiplied by the numerator or by the whole fraction?
The numerator. Yeah.
So it's r times sy all over s of x.
It's kind of tomato.
Oh, it doesn't matter.
It's either you can r or r.
Oh.
Just don't multiply it on top and the bottom. Right? So it doesn't really matter. You're going to end up with the same answer. Just don't multiply it on the top and the bottom. I'm just telling you things I see.
No, I was just going to say, is there going to be they're not taking my calculator away from me, right?
No, they are not taking your calculator away.
Oh, so this question is how do we find, because if there's a question where it's like, which equation is how you find the expected value?
Right. Or they're could be a multiple choice that says, show how you would calculate the expected counts for this value on a free response. And you saying calculator commands is not going to cut it, right? I don't know. I don't get to see the questions until after you've done them. So that's the row total times the column total divided by the table total. What are your outlier formulas? What are your fences? How do you find the IQR? Q3 minus Q1. What percent of the data does the IQR include? 50%, right? It's the middle half of the data. Yeah, so it's the middle 50% is your IQR, which means 25% of the data is above Q3 and 25% of the data is below Q1. What is the 5-number summary, and does your calculator calculate it for you?
Yes.
It does. Right. Min, Q1, medium, Q3, and max. And if you do 1 var stats, your calculator will give that to you.
What is the formula for a z-score?
It's the sample minus mean over standard deviation. So it could be x minus mu over sigma. It could be x bar minus mu over sigma over square root n. It can be p hat minus p naught over square root of p hat q hat over n, which is why we just say our sample minus the mean of the distribution divided by the standard deviation, because that can take a lot of different forms. What's what? The 68, 95, 99.7 rule.
God, I wish you just asked us a bunch of what is the average?
I know. Now, we did not ever straighten scatter plots, so hopefully we're just going to take an L on that multiple choice question. Okay, so the next thing we didn't get to in class is how do we interpret S? S is the standard deviation of the residuals. S is given to you in the regression output. So it's the average variation in the residuals. How do we calculate residuals? It's the actual or the observed, so the actual data point minus what the equation predicts. So you would plug your x value into the equation to find the predicted, and then you subtract it from the actual data value. Remember that a positive means it's above the line and a negative means it's below the line. The difference between the population and the sample. The population is everybody you're interested in. So every student at Elsinore, if we were interested in that sample, that is our population. And then we take 100 students from Elsinore, they are our sample. The parameter is the mean of all students at Elsinore, and a statistics would be the mean from our sample of 100 students from Elsinore. There's 3 types of bias: under coverage, or selection bias, where not everybody had an equal chance of getting chosen. So that's if you don't have a phone number, and it was random digit dialing, you didn't have a chance to get chosen. We have response bias, where something about the survey is causing you to answer a certain way, something about the person who's asking the question, the way you're asking the question. And then there's non-response bias, which is just people not answering your questions. What are the 2 types of observational studies? Prospective. Prospective is where you were to follow someone for 12 years and gather data as they live their life. And retrospective is where you look into the past and you gather data from past records. An observational study is just watching people as they live or looking into old data. An experiment imposes a treatment. We can determine some causal relationships from experiments, but never from an observational study. The 4 design principles are control. You have to control everything you can to keep from confounding variables. Randomize. How are you going to randomize the experiment? How are you going to replicate it? You can't just have one person in your study or 2 people in your study. You've got to have several. And then the last one is not control. Again, it's blocking. Is there a necessity for blocking where you separate them by male or female because you think that they lose weight differently and that it's a weight loss drug? You block for that, and then you do the control and randomization and replication within your blocks. The stratified sample is where we have homogeneous groupings. So we have groups that have a variable in common, and then we do random selection within the groups. And then the cluster sample is heterogeneous grouping, and we sample the entire group. So stratified is like, I want to pick 100 students from each grade level. And then I sample, so my strata are the grades, and then I randomly select within the strata. The cluster are, I pick electives that have groups of all grade levels, and then I pick 2 or 3 classes, and I select everybody within that class. That's kind of the same thing as stratified, but what is a simple random sample? It's each group of n has an equally likely chance of being chosen. Each group of size n has an equally likely chance of being chosen, selected. So to do a simple random sample of the school, you would give everybody a number from 1 to however many there are, 1,800, and you'd randomly select 100 students from there. Each group of 100 had an equal chance of being chosen because we're not separating them. In a stratified and a cluster sample, not every grouping is possible because you're not going to get, if you're doing a sample of 500 of each group, of 4 groups, you're not going to get 400 from the 9th graders. The difference between double blind and single blind. The double blind is where both the evaluator and the subject do not know what treatment is being imposed. And the single blind is where only the subject, or sometimes it could be the evaluator if the subject is like a tomato. The placebo is a treatment that has no effect. A sugar pill, giving it water instead of water with fertilizer in it. So the placebo is like the non-effect. It's usually the control group. It's the treatment that isn't expected to do anything. Confounding variables are variables that affect the study because they weren't controlled for. When we did our Coke experiment, if I had used Coke and Diet Coke, sugar would have been a confounding variable because there's a difference in the amount of sugar in each soda. And so the sugar could have caused an increase or decrease in heart rate as opposed to it being caffeine. So you don't know whether it was from the caffeine or from the sugar. The mean of a random variable, remember that's expected value. That's the sum of x times the probability of x. That's using our probability models like $50. The chance of winning $50 is 1 over 52 if you get an ace. And the chance of winning $5 is 10 out of 52. And then the chance of losing $5 is 1141 out of 52. And I'd multiply 50 times 1 over 52 plus 5 times 10 over 52 plus negative 5 times 41 over 52. And then I'd add that all up. In the calculator, we can do one var stats, and we put our x in list 1 and our probability in the frequency in list 2, and then we let that be our frequency list. When we combine two random variables, the standard deviation is the square root of sigma squared 1 plus sigma squared 2. And our z interval is p hat plus or minus z star, square root of p hat q hat over n.